Hello and welcome back to the Swift programming course. Today you'll be learning about structures in Swift. A structure is a value that is always copied when it's passed around. An example of this is a quadrilateral shape or a triangle shape. We can give these values and reference to them and give them new values. So let's create a quadrilateral structure to calculate the area of a quadrilateral. So let's create a struct. We can do this by doing struct and then doing the name of the structure. So I'm going to do quadrilateral and then I'm going to define the quadrilateral structure in here. Then we're creating the variable width and we're having that as a type integer. We're setting that to 0 to kind of template our answer that we'll provide later when we reference to the structure. So let's create our variable height and have that equal to 0 also. And now we're needing to use a function. Now if you watched my last video in the programming course, then you'll know what a function is and how we can create one in Swift. So let's do function, and we're going to create a function called area and return that as an integer. And we're going to write in there return width times height, which is the way we find the area of a shape. We multiply the width by the height and then we get the area. Okay, so now we've created our structure, we need to create properties for the structure so that we can actually use it, because it's great that we've got this, but it does nothing right now. So we're going to create another variable called quadrilateral, but this time without the capital letter. You see these two instances are completely different. And then we're going to set it to the function. So you can see why we needed different capitalization in our function and our variable name. Then we need to reference the variable we've just created, so quadrilateral, and then we're going to do dot width and set our width. So in this case I'm going to do 12 and set the quadrilateral height, and I'm going to do 4, and if I'm right that should create an area of about 47, 48, working that out in my head. So we're going to do print line quadrilateral dot area. So we're going to reference to this function that we created up here. So yeah, 48. So what we're doing in this piece of code is we're saying we're printing the line quadrilateral, which is the variable reference to this class, or this structure, sorry. So we're passing through to the structure and then inside of the structure to the function, which we're calling here with empty parameters, and then closing off that printed line. So you can see that we've provided it with a width and a height, and it's then multiplied the width by the height to give us an area of 48, which is exactly what we want this to do. Now we could actually enter in alternate information. We don't just have to do 12 and 4, we can find out other areas as well, which is absolutely great. So for example 4 and 2, and then we'd get 8. And the previous code, the previous answer, sorry, is completely the same. It hasn't changed this one to this one, has it? We can reference to it and we can change. Well, it's a value that is always copied when it's passed around, right? So we can change the values, but they can be copied as well. And that's the interesting thing about it, and it's really cool. Now we don't have to just stick to quadrilaterals, we can do it with more complex things like triangles. So we can have a width, and a width, so 3 equal sides, so they're all going to be the same because that is a triangle, a shape with 3 equal sides. We could also do this with a right angle triangle with 3 different sides, and we could do Pythagoras' theorem, where we need to find the area of 2 shapes, and then what we need to do is add them areas up and find the square root to find the hypotenuse, and we could do that with this method as well. It's really interesting. So let's do another example and just split this code up a little bit, and we're just going to do a little pattern there just to identify ourselves. So we're going to create another structure and call this structure's triangle. So here we're going to find the perimeter of a triangle instead of the area. So we're going to create a variable width 1 and have that equal to an integer type of 0 again, and then we're going to do width 2 and width 3. So these are all placeholders for the information that we'll provide the code with later. and again we're going to create a function, this time call it perimeter, returned as an integer. So we're going to return the value of width 1 plus width 2 plus width 3, which is how we'll find the perimeter, because you calculate the space around a shape to find the perimeter of one shape, but since we've got 3 shapes, so kind of multiple widths, we will add them widths in order to find the complete perimeter of the whole shape, since we've got kind of three sides of it and we need to add them together, if that makes sense. Okay, and now we need to create the properties for this triangular structure that we've created. So we're going to create a variable triangle and have that equal to the triangle function. You can see the pattern here, since we're not using capitals and then using capitals, it's the same pattern. So triangle dot width 1, we can set that equal to anything we want. 2 triangle dot width 2, I'm going to have that equal to 5, and triangle dot width 3, I'll have that equal to 11. If I'm right, this should create a perimeter of 18. So let's test this now. So triangle dot perimeter, and let's call that. So we should, yep, we got 18. So this structure is a value that is going to be copied when it's passed around, so we can calculate the perimeter of any triangle. Now we don't just have to find area and perimeter. Like I said, we can find more advanced things like Pythagoras' theorem, the hypotenuse of a shape, the value of a shape. We can do so much more with these structures, and if you think about it in your head really carefully, then you'll start to understand it a bit more. So a structure is a value that is always copied when it's passed around, and we can use this type of method to create different structures to calculate the area or the perimeter or Pythagoras' theorem, the hypotenuse, any type of thing we want to do with a structure. We can take parts of that structure and create methods and functions, and we can do a hell of a lot of stuff with them. It's a really cool mathematical way of expressing things. And that was structures in Swift.